Good evening, dear students. Yesterday we have started with amines, right? So, what are things we have discussed in amines? So, we have discussed about what are amines, right? We know that amines are the derivatives of ammonia, okay, in which one or more hydrogen atoms can be replaced with alkyl or a aryl group, right? So, these things we have discussed in the last class. Then we have seen the classification of amines, okay? Basically, they are classified as primary amines, secondary amines, and tertiary amines. Okay, based on how many hydrogen atoms are replaced by a alkyl or a aryl group. Right. Then we have seen the nomenclature, how to name the amines. Okay. So these all things we have discussed about amines. Then we have also discussed about the preparation of amines, right? How we can prepare amines. So first was by reduction of nitro compounds. So by using a reducing agent, we can convert the nitro compounds into what? Into amine. So here you can see. So basically, which reducing agent we can use? We can use tin HCl. Okay, tin in the presence of concentrated HCl. You can also use FeHCl. Okay, and you can also do catalytic hydrogenation. That is hydrogen in the presence of, you can either use nickel, palladium, or platinum. Okay, so in the acidic medium, so the you can convert the nitro compounds into amines. Okay, so this was about the first preparation. Then we have discussed about the ammonolysis of alkyl halides. Okay, so what we are doing, we are breaking the CX bond by ammonia molecule. Okay, so what you can see, so at each step what you're adding a hydrogen halide, okay, at each step. So you're going to get a mixture of primary, secondary, okay, and tertiary amines. Okay, so here we have done the ammonolysis. Okay, next we have also seen the reduction of nitriles. Again, nitriles are nothing but cyanides. Okay, we are using a good reducing agent like lithium aluminum hydride, or also you can use catalytic hydrogenation. Okay, that is H2 in the presence of nickel, and they produce primary amines. Okay, so RCN in the presence of lithium aluminum hydride, you can use a agent, okay, solvent like dry ether. What I'm going to get is, I'm going to get a amine. Okay, so different preparations where we can prepare the amine. So another, by reduction of amides. Okay, so by using a reducing agent, we can reduce the amide into amines. Okay, so here also we can use, so amide, you can see here amide is converted into amine. So either you can use lithium aluminum hydride, or also you can use sodium in alcohol. Okay. Yes. Next, also we have seen about Hoffman bromamide degradation reaction. Okay, so you can see by this method you can prepare a primary amine. Okay, you have to only treat it with a bromine. Okay, in aqueous or ethanoic solution of your sodium or potassium hydroxide. Okay, then here what you can see, the in the product, okay, you can see the amine which is so formed, it has one carbon less, okay, as compared to that of your parent amide. Okay, so like this you can prepare primary amine. So your only primary amines can be prepared from Hoffman bromamide degradation reaction. Okay, yes. Then we've also discussed about the Gabriel thalamide synthesis. So what do you mean by Gabriel thalamide synthesis? Yes, thalamide is taken. Okay, we are reacting with KOH, potassium hydroxide, to give you a potassium salt of thalamide. This potassium salt of thalamide further reacting with what, alkyl halide, giving you N-alkyl thalamide. This N-alkyl thalamide further undergoes base hydrolysis to give you a thalamate, okay, and you're going to get this sodium thalate and your primary amines is the product which you obtain. Okay, from Gabriel thalamate synthesis, you can prepare only aliphatic primary amines. Okay, aromatic primary amines they cannot be prepared by this method. Okay, because here what we are using a alkyl halide, right? So we cannot use any aryl halide. Okay, because aryl halide does not undergo any nucleophilic substitution reaction. So for that reason, okay, Gabriel thalamate synthesis is only used for the preparation of primary primary aliphatic amines. Yes. Also, we have started with the physical properties. So we have discussed in the last class about physical state, odor, solubility, okay, about the boiling point, okay. And then we have started with the chemical properties. So we have discussed about the basic nature of amines, right? Then we have discussed about the strength, okay, aliphatic amines, okay, they are stronger than the monomer. Okay, then we have then we have seen the acylation, right? So we have discussed about the acylation, alkylation. So these reactions we have discussed the chemical reactions, right? Acylation, alkylation. So reactions we have discussed. Okay. Then we had started with the uh, carbalamine reaction. So very, very important. I have told you, mark this as important. Okay. Here the primary amines, okay, they undergo, we are going to heat them, okay, in the mixture of the chloroform and alcoholic KOH. Okay. What it forms? It forms isocyanate. So isocyanate is what? Here the alkyl group is attached to nitrogen. Okay, so this is your what? This is your isocyanate. So isocyanate. Okay, so aliphatic and aromatic primary amines on heating with chloroform and ethanoic potassium hydroxide. Okay, we are going to get isocyanate, or they are also called as carbalamines. Okay, and these carbalamines are foul smelling. Okay, that is they are very they have a very bad smell. Okay, so from this method, only primary aliphatic amines, okay, we can only do reaction on them. We cannot use secondary and tertiary amines. Okay. So this is about carbolamines. Okay. So next is reaction with nitrous acid. Okay. So yesterday we were seeing this. So amines, when they react with nitrous acid, how do we get nitrous acid? I have told you, when sodium nitrate NaNO2 reacts with concentrated HCl, we get what? We get nitrous acid, HNO2. Okay, so when amines, okay, so when amines, when you react it with nitrous acid, okay, I'm going to get a diazonium salt. Okay, I'm going to get what? I'm going to get a diazonium salt, and this diazonium salt is unstable. RN2Cl. Okay, it is unstable, and further, okay, it will react with any suppose alcohol, water, and it forms a alcohol plus HCl plus N2 gas. Okay, so it is unstable. This is unstable. Okay, it is unstable. So it forms alcohols and it will liberate the N2. So this is the reaction with nitrous acid. Okay, how the nitrous acid is formed. So here you can see, so we have taken aniline. So aniline is there. Aniline is reacted with sodium nitrate in the presence of concentrated HCl. You get a benzene diazonium salt. Okay, you get a benzene diazonium salt. Okay, you can see how is the structure. So benzene N2Cl. Okay, this benzenium salt, as you know, N2 is an excellent living group. Okay, so it can all type of reactions are possible over here. So you can add your alcohol, you will get a hydrocarbon. If you add cuprous chloride, you are going to get chlorobenzene. Cuprous bromide, you are going to get bromobenzene. With potassium iodide, I am going to get iodobenzene. With water and NaOH, when you heat it, I'm going to get alcohol. If you react it with HBF4, I'm going to get a fluorobenzene. With copper cyanide, I'm going to get a cyanobenzene. Okay. With NaOH, I'm going to get para-hydroxyazobenzene. Okay. So these are the different reactions possible when you react with arene disonium salt. Okay, so these things we have discussed in the last class. So next we are going to see the what electrophilic substitution reaction. Okay, we are going to see the electrophilic substitution reaction. So here, so this reaction, so what we were discussing here last, so aromatic primary amines, okay, when they react with nitrous acid, they react at a very low temperature. The temperature condition should be at 0 to 5 degrees Celsius. Okay, the temperature condition should be 0 to 5 degrees Celsius. Okay, the temperature condition is 0 to 5 degrees Celsius. And what it forms a disonium salts. Okay, and these reactions are called as disonium reactions. Okay, diazotization reaction. Okay, they are called as what? Diazotization reaction. Okay, they are called as diazotization reaction. Understood? So aromatic primary amines react with what? They react with nitrous acid. Okay, at a very low temperatures, that is 0 to 5 degrees Celsius, and it forms disonium salt. Okay, and this is called as diazotization reaction. Okay, so and secondary and tertiary amines, they react with nitrous acid, but they react differently. Okay, yes. So let us see about Hinsberg reagent. So let us see about Hinsberg reagent. Okay, so let us see about Hinsberg reagent. Okay, so this is a test. Okay, this is a test which is used to distinguish between primary, secondary, and tertiary amine. Okay, so when we are discussing about the Hinsberg reagent, so what you have to remember that this is a test, okay, which is required or this is used to distinguish, okay, to differentiate between primary, secondary, and tertiary amines. So what is Hinsberg reagent? It is benzene sulfonyl chloride. Okay, it is benzene sulfonyl chloride. It is C6H5 SO2Cl. Okay, you can see this is a structure. So benzene sulfonyl chloride. So what I am going to do? So this is known as Hinsberg reagent. So this reacts with primary and secondary amines and it forms what? Sulfonamide. So you can see here. Okay, so first reaction is with primary amine. So we have benzene sulfonyl chloride. Okay, so benzene sulfonyl chloride reacts with a primary amine. Okay, with a primary amine and it forms N-alkyl benzene sulfonamide. Okay, and this is soluble in, okay, it is soluble in alkali. Okay, this is soluble in alkali. So what is happening here? You can see the hydrogen atom. Okay, the hydrogen atom which is attached to the nitrogen. Okay, in the sulfonamide, this is strongly acidic. Okay, this is strongly acidic because of the presence of strong electron withdrawing group. Okay, because of the presence of strong electron withdrawing group. So because of that, it is soluble. Okay, because of that, it is soluble in alkali. Okay, because of that, it is soluble in alkali. So, okay, so like this will be the first test with Hinsberg reagent. Then, if we react the sulfonyl chloride with secondary amine, okay, so this is a secondary amine. So, when we react it with secondary amine, it forms NN-dialkyl benzene sulfonamide. Okay, and this is insoluble. Okay, this is insoluble. Okay, what? It is insoluble in alkali. Okay, when you take the benzene sulfonyl chloride, react it with secondary amine, it is insoluble. What is the product? It is NN-dialkyl benzene sulfonyl chloride. So what you can see in the structure of NN-dialkyl benzene sulfonyl chloride, there is no acidic hydrogen. Okay, as you can see here, there is acidic hydrogen. There is no acidic hydrogen in this case, right? In this structure. So it is insoluble in alkali. Okay. So it is insoluble in alkali. So because there is no acidic hydrogen, it is insoluble in alkali. So this is the second reaction with secondary amine. Then tertiary amine. So take again benzyl sulfonyl chloride react with tertiary amine. They do not give any reaction. So there is no reaction. Okay, so there is no reaction. So tertiary amines does not give any reaction. Okay. So primary, secondary, and tertiary, how they react, tertiary amines, they react differently. Okay, they react differently with this benzyl sulfonyl chloride. Okay, so it is used as a distinguishing test for primary, secondary, and tertiary amine. As we know, so with primary amine, what it forms, it reacts with benzyl sulfonyl chloride and it forms N-alkyl benzene sulfonate. Okay, which is soluble in alkali. Okay, and benzene sulfonyl chloride, when it reacts with secondary amine, it forms NN dialkyl benzene sulfonate. Okay, but it is insoluble in alkali. Why? Because there is no acidic hydrogen. And third one, benzene sulfonyl chloride, when it reacted with tertiary amine, there is no reaction. Okay, there is no reaction. Is it clear? So very, very important about Hinsberg reagent. About Hinsberg reagent. Next, we are going to see about the electrophilic substitution reaction. Okay, next we are going to see about what? We are going to see about the electrophilic substitution reaction. So what do you mean by electrophilic substitution reaction? Yes. So here, when you see amine, okay, when you see a amine, so what you can see, when you see amine, okay, this is a aniline. Okay, the simplest is the aniline. So in the aniline, you can see this NH2. Okay, in the aniline, what you can see, what you can see is the NH2. Okay, so this NH2 group, it is a deactivating group. Okay, it is a activating group and it will activate your benzene ring at orthopara direct. Okay, it will whatever the incoming electrophile is there, it will be directed to orthopara group. Okay, so NH2 group, it is what? It is a highly activating group. It will activate your benzene ring and further reaction of the electrophile, it will direct the incoming electrophile to orthopara position. Okay, so first let's see about bromination. Okay, let us see about bromination. So what we have done, we have taken aniline. Okay, this aniline reacts with bromine water. Okay, in the presence of bromine, okay, in the presence of bromine water at room temperature, it gives you 2,4,6 tribromoaniline. Okay, it forms 2,4,6 tribromoaniline. Okay, so however, if there is a monosubstituted derivative, okay, if you require a monosubstituted derivative, what you have to do? First, you have to first you have to acylate with the acetic anhydride and then you have to do halogenation. Okay, then you will get the this what um, you will get the monosubstituted amine. Now this is a tri-substituted amine, right? So if you want monosubstituted amine, first you have to do the acylation. Okay, you have to acyl the group, so it will be protected, and then you are going to do the mono substitution. Okay, so that is about your bromination. Next, we are going to see is about the what we are going to see is about the so here you can see. Okay, so I'll write the reaction. Okay, so what we have discussed just now. So when we have the monosubstituted, so how we are going to do that? Suppose this is your aniline. Okay, this is my aniline. Okay, I'm going to do what I said, acetylation. So how I'm going to do? I'm going to take acetic anhydride. Okay, I'm going to take acetic anhydride. This acetic anhydride, I'm going to react it in the presence of a base. So what I'm going to get? So my this group, okay, NH, okay, C double bond O, CH3. So I got what? I got acetanilide. Okay, I got acetanilide. This acetanilide further again, I'm going to react it with bromine and acetic acid. Bromine and acetic acid. Again, what I'm going to get? So whatever the NH C double bond O CH3. So I'm going to get at your para position. Okay, at para position, I have the bromine group, right? So further, I'm going to do what? I'm going to do acid base hydrolysis. So what will happen? Your NH, this, okay, it will followed by hydrolysis. Okay, so I'm going to get my aniline back. So it is 4 bromoaniline. So like this, we can get the monosubstituted compound. Okay, we can get the monosubstituted compound. So next is nitration. How we are going to get the nitration? So here you can see here how we have done just now, right? So this protection. So how we can do the single this, right? Okay, so this we have discussed now. So next is nitration. So nitration, how we are going to do nitration? So direct nitration of aniline, okay, will give you three oxidation products. Okay, so in the strongly acidic medium, aniline is protonated to form the aniline ion, which is meta-directing. Okay, that is why beside ortho and para derivatives, significant amount of meta derivatives also formed. So what is the reaction talking about? Okay, so when we have a, so here you can see, so we have an aniline. Okay, so aniline in the presence of HNO3 and H2SO4 at 288 Kelvin, we are going to get para product. So this is a para, this is a meta, and this is a ortho. Okay, so we have ortho nitroaniline, we have para nitroaniline, and we have meta nitroaniline. So all the three products are formed. Okay, the aniline when it reacts, okay, with nitration when we do, so all the three products are possible. So but if I want a monosubstituted, if I want a monosubstituted product, so first step again, what I have to do? I have to do first the acetylation. Okay, I have to acyl the group. I have to protect my NH2. So first, I am going to protect it with acyl group. So I am taking acetyl chloride. So what will happen? NHCOCH3 you will get. Further, you do the nitration. Okay, nitration is carried out in the presence of what? HNO3 and H2SO4. What I am going to get? Paranitro Okay, further again, upon hydrolysis, what I am going to get? I am going to get the what? Our this what? 4 4 aniline, mono substituted product. Okay, when we want a mono substituted product. Okay, so yes. So next is sulfonation. Next is what? Sulfonation. Okay, so how we are going to get the sulfonation? So we are going to take, so important, mark this as important. So aniline, okay, it is going to react with concentrated sulfuric acid, okay, and you are going to form a anilium hydrogen sulfate, okay, which on further heating with sulfuric acid at 453 to 473 Kelvin, you are going to produce para amino benzene sulfonic acid, which is also called as sulfanilic acid as a major product. So let us see the reaction. So this is a reaction, what you can see. So we have aniline here. Okay, we have aniline. We are going to react it with H2SO4. I am going to get the aniline hydrogen sulfate. Okay, I am going to get the aniline hydrogen sulfate. So let me write the reaction. Okay, so let me write the reaction over here. So the reaction goes like this. So I have aniline. Okay, aniline reacted with H2SO4. Okay, what I'm going to get? What I'm going to get? I'm going to get NH3 plus HSO4. Okay, so this is my aniline. Okay, hydrogen sulfate. This on further reacting with H2SO4 again at 453 to 473 Kelvin. I am going to get what? I am going to get sulfanilic acid. Okay, I am going to get sulfanilic acid, SO3H. So this is sulfanilic acid. So this is the reaction. So mark this as important. There can be question. Okay, give the sulfonation reaction on aniline. So this way you have to. So this is a major product. Okay. So this is a major product. Okay. And this Friedel, what is uh, aniline? Okay, it does not undergo Friedel-Crafts reaction. It undergoes only nitration, halogenation, and sulfonation. Okay, it does not undergo Friedel-Crafts reaction. Yes. So next we are going to discuss about something called as diazonium salt. So so we have discussed about the amine. So our next chapter is we are going to discuss about diazonium salt. Now, what do you mean by diazonium salts? Yes, diazonium salt. So just now we have seen that. Okay, so aniline. Okay, aniline is there. So aniline, when you react it with nitrous acid, how you get nitrous acid? In the presence of NaNO2. So NaNO2 plus concentrated HCl. Okay, so the temperature condition is important, 273 to 278 Kelvin, or it is 0 degree to 5 degrees Celsius. Okay, what I am going to get? I am going to get N2 plus Cl minus. Okay, so this is benzene diazonium salt. Okay, so this is benzene diazonium salt. So, and this is unstable. So the formula is Rn2 plus X minus. Okay, so this is about the diazonium salt. So what are diazonium salt? Okay, so it is the formula is Rn2 plus X minus. So your R can be alkyl or it can be aryl. Okay, R can be alkyl or it can be aryl. What is N2 plus? N2 plus is called as the diazonium group. Okay, it is called as the diazonium group. Okay, so it is like this, N plus, okay, with lone pair. So like this. Okay, so this is the diazonium group, how we represent. And your X minus, it can be your Cl minus, it can be Br minus, it can be HSO4 minus. Okay, it can be BF4 minus, etc. Okay, so this is about diazonium salt. Is it clear? Okay. Next, we are going to see the nomenclature. Next, we are going to see about the nomenclature, how to name this. Okay, how to name the diazonium salt. Okay, so these salt, they are named by putting the suffix. Okay, diazonium, you have to put the suffix diazonium to the whatever the parent hydrocarbon is there. Okay, so suppose if it is like this, so this is N2 plus and Cl minus. So what will be the name? It is benzene. It is benzene diazonium. Okay, benzene diazonium. And what is the anion? It is a chloride. Benzene diazonium chloride. Okay, benzene diazonium chloride. So this is one example. Another example I'll give you. Another example. So N2 plus HSO4 minus. What is the name? What is the name? So this name is benzene diazonium. So benzene diazonium hydrogen sulfate. Okay, it is benzene diazonium hydrogen sulfate. Okay, so like this, you are going to name the diazonium salt. Okay, so this is about the nomenclature. Okay, yes. So this benzonium, so when the primary aromatic amine, this is nothing but primary aromatic amine, right? Your aniline. So aniline is a primary aromatic amine. Aromatic amine, they form arene diazonium salt. Okay, they form what? Arene diazonium salt, like this. Okay, these are the arene, N plus Cl minus. So triple bond. Okay, so this is arene diazonium salt. So this arene diazonium salt, okay, which are stable at low temperature. They are stable what? They are stable at low temperature only. Okay. Okay, so this arene diazonium salt, they are stable at low temperature. Okay, while your aliphatic amines, okay, they form highly unstable alkyl diazonium salt. Okay, so the stability, it depends on the resonance structure. So if I write the resonance structure, okay, So N triple bond N. Okay, so minus plus. So if I so there is a resonating structure. Okay, the electron charge is it will delocalize. Okay, it will delocalize. So like this. So this is the okay. So these are the resonating structures, okay, of the arene diazonium salt. So these arene diazonium salt, they are more stable than your alkyl diazonium salt. Alkyl means when they are in aliphatic form, but when you see the arene diazonium salt, okay, they are more stable. Fine. Yes. So next we are going to see the methods of preparation of diazonium salt. Okay. So first one, that is primary aromatic amine. Okay, so amine is there. So aniline, I'm going to take aniline. I'm going to react it with how we are going to form. So NaNO2 plus HCl. Okay, at 0 degrees Celsius to 5 degrees Celsius. So we have aniline. Okay, this aniline, when you treat it with NaNO2 plus HCl at 0 to 5 degrees Celsius, I'm going to get what? N2 plus Cl minus. Okay, N2 plus Cl minus, that is called as benzene diazonium chloride. Okay, it is called as benzene diazonium chloride. This benzene diazonium chloride plus I am going to get NaCl plus H2O. Okay, so like this, I'm going to form the benzene diazonium chloride. Okay, now let us see the reactions. Okay, the chemical reactions which are involving. Okay, so chemical reactions of the benzene diazonium salt. So the chemical reactions, they are categorized into two types. First is the reactions which are involving the displacement of nitrogen. Okay, then second one is the reactions involving the retention of diazo group. So there are two reactions. The first reaction, chemical reaction, involves the displacement of nitrogen, and second is the chemical reactions which involves the what the retention of diazo group. So first one, when you see the displacement of nitrogen, okay, so we have taken this. So let me take directly the benzene diazonium salt. Okay, so I have benzene diazonium salt, that is Ar N2 plus and X minus. So from this, okay, we can use different okay, so I can replace the diazo group. Okay, so first if we are replacing the halide ion, okay, or the this, so what you can do, you can react it by CuCl2 in the presence of HCl, or you can react it with Cu2Br2 in the presence of HBr. Okay, or you can react it with CuCN minus and in the presence of HCl. So what I can get? I can get your chlorobenzene, okay, Cl plus N2, this is liberated. Here I can get Br, okay, that is bromobenzene plus N2 gas is liberated. And at last, if we use this, we can get Cn plus N2 gas is liberated. Okay, so replacement of this halide. Okay, we can replace the halide ion or the cyanide ion. So you can see the diazo group. Okay, so in this reaction, the diazo group is replaced. Okay, we are replacing the diazo group by the what? By the nucleophiles. Okay, and you can see the nitrogen gas is released. Okay, nitrogen gas is released. So here, when we are reacting it in the presence of in the presence of copper and HCl, which gives rise to chlorobenzene, and when N2 this your diazo group BDC, okay, BDX, you can say benzene diazonium halides. When they reacted with copper in the presence of HBr, it gives you bromobenzene. So these reaction, okay, where we are introduced the we are where in the in the benzene ring we are introducing chlorine or the bromine, okay. Then by replacing the that is by treating the diazonium salt, okay, with the corresponding halogen acid in the presence of the copper, okay, then these reactions are called as the Gattermann reaction. Okay, so these two reactions, they name it as Gattermann reaction. Okay, how they are Gattermann reaction? Because it takes place in the presence of copper powder and respective halogen acid. Okay, yes. So next reaction, we are replacing your this N2 plus and X minus plus Ki. Okay, when you react the benzene diazonium halide, okay, when benzene diazonium salt is treated with Ki, we are going to get what? We are going to get idobenzene. We are going to get idobenzene plus N2 gas is liberated plus Kx. Okay, so this is another reaction. Okay, idobenzene. Now, if I want this what fluorobenzene. Okay, so how I am going to get the fluorobenzene? So again, take what I'm going to take N2X, okay, that is N2 plus X minus, react it with, so diazonium salt, react it with your fluoroboric acid, that is HBF4, okay, HBF4, and I'm going to get, so this is what hydrofluoroboric acid. So I'm going to get what? I am going to get first N2 plus and BF4 minus. Okay, when you further heat it, I am going to get fluorobenzene. Okay, I am going to get fluorobenzene plus N2 gas is liberated plus BF3 plus BF3. Okay, so this is the another reaction. This is called as the Balch-Schiemann reaction. Okay, Balch-Schiemann reaction. Okay. Next, we are going to see the replacement by hydrogen. Okay, replacement by hydrogen. So take, so we are going to take the benzene diazonium chloride. Okay, react it with H3PO2 in the presence of water. Okay, what I am going to get? Okay, so another reaction where we are replacing the benzene diazonium salt, okay, with now we are reacting with CH3 CH2OH. So what will be the product? I am going to get benzene. Okay, I am going to get benzene plus N2 gas will be liberated plus CH3 CHO plus HCl. Okay, so here what we are doing, we are replacement of hydrogen. So these are all reductions. Okay, replacement of hydrogen, that is all reduction reactions. Okay, so now let us replacement of hydroxyl group. Okay, replacement by hydroxyl group. So let us see. So again, benzene diazonium chloride. So take benzene diazonium chloride N2 plus Cl minus, react it with water. Okay, at 283 Kelvin. Okay, at 283 Kelvin, what I am going to get? I am going to get the N2Cl will be replaced by OH plus N2 gas is released plus HCl. So I am going to get a phenol. Okay, so this is replacement by OH. Okay, replacement by hydroxyl group. Okay, replacement by hydroxyl. Hydroxyl is nothing but OH group. Okay, yes. Then next is replacement of nitro group. Okay, replacement of nitro group. So how we are going to do replacement of nitro group? So take again N2 plus Cl minus. Okay, react it with what? React it with HBF4. Okay, that is fluoroboric acid. I am going to get what? I am going to get, okay, so I am going to get N2 plus BF4 minus, further treat it with sodium nitrate NaNO2 in the presence of copper, heat it. I am going to get nitrobenzene. Okay, I am going to get nitrobenzene plus N2 gas plus NaBF4. Okay, plus NaBF4. So like this, we are replacing the diazo group by nitro group. Okay, is it clear? Yes. So next we are going to see the coupling reactions. Okay, next we are going to see the coupling reaction. That is, we are retaining the diazo group. Okay, so the first example is we are going to take the, okay, so this is our N. So same N plus Cl minus. Okay. So this is our benzene diazonium chloride. I have taken ulta. Okay. I have taken in reverse manner. So benzene diazonium chloride. Okay. Benzene diazonium chloride. I am going to react it with phenol. Okay. I am going to react it with what? I am going to react it with phenol. Okay. So what I am going to get? What I am going to get with phenol? Okay. In the basic medium. Okay. In a basic medium. So I am going to get a, so N double bond N, okay, and this will be OH plus Cl minus plus water. So this is a para-hydroxy. So para-hydroxy azobenzene. Para-hydroxy azobenzene. So very, very important. Okay, very, very important. So para-hydroxy. So this is a azo di. So diazonium salts. Okay, when they react with such aromatic compounds like your phenol or aniline, okay, in a very ice cold solution, they form bright colored dye. Okay, and these are called as the azo-dyes. Okay, so this is an example of electrophilic substitution reaction. So this is the orange dye. Okay, this gives rise to orange dye. Okay, so next one, so one more. So take again benzene diazonium salt. Okay, take benzene diazonium salt. So N triple bond N plus Cl. Okay, react it with the aniline. Now react it with aniline. So I'll erase this. Okay, we'll write it again here. So take benzene. Okay, so N triple bond N plus Cl minus. React it with what? Aniline. Okay, we are reacting it with aniline. That is NH2. Okay, aniline. Then what I'm going to get in the acidic medium? I'm going to get the azobenzene. Okay, again azo dye. So N double bond N. Okay, and NH2. So this is what? Para-amino benzene. Para-amino azobenzene. Okay, and this is yellow color. This is yellow dye. Okay, this is yellow dye. So these are both azo retention of azo group. Azo group means N double bond N. Okay, retention of diazo group. Sorry, retention of diazo group. So in both this reaction, we are keeping the diazo group, right? We are not removing. So we have seen two type of chemical reaction. One chemical reaction, it involves the removal of the your this what in that we are removing the your diazo group and we are replacing it, okay, by other nucleophiles. But here what you can see here in this type of reaction, we are retaining the diazo group. So there are two reaction. One is the formation of hydroxyazobenzene, that is orange dye. Okay, we are going to react the benzene diazonium salt, okay, benzene diazonium chloride with your phenol. Okay, and we are going to get a para hydroxyazobenzene. And another is what? Another is benzene diazonium salt. We are going to react it with aniline. Okay, yes. So these are the different reaction. Okay, so what are, why are these important? Okay, what is the importance of this diazonium salt in our synthetic organic compound. So your diazonium salts, they are the good intermediate. Okay, for introduction of F. So we have seen different groups, right? So by treating your benzene diazonium salt, that is N2 plus Cl minus. Okay, by treating your benzene titanium salt, that is N2 plus and Cl minus, we have introduced different groups, right? Fluorobenzene, chlorobenzene, bromobenzene, idobenzene, cyanobenzene, phenol, nitrobenzene, right? Into the aromatic group. So this is a easily replaceable group. Then your aryl fluorides and iodides, they cannot be prepared by direct halogenation, but by using the diazonium salt, it can be easily obtained. By using diazonium salt, you can easily prepare idobenzene and your fluorobenzene, but we cannot prepare directly. And this diazonium salts, they are used in the preparation of various azodyes. Okay, so we have seen the azodyes, right? Azodyes. So in the preparation of azodyes, it is mainly used. Okay, so is it clear? Yes. So this completes your chapter amines. Okay. So we have completed the chapter amine. Any doubts up to here? So what all things we have discussed? We have discussed about the amines. Okay, we have discussed the what are the amines. We have seen the classification, nomenclature. We have discussed about the methods of preparation. We have seen the structure of amine. Okay, methods of preparation of amine. Then we have seen the physical properties, different physical properties. Then we have seen the chemical properties, right? Then we have discussed with the what are your this what different chemical properties. Then we have started with what are diazonium salts. Okay, then in diazonium salt we have discussed the methods of preparation of diazonium salt, right? Then we have discussed the chemical reactions. Okay, and in chemical reactions, we have seen two type of chemical reaction. In one, which there is a retention. Okay, in one there is a retention of the diazo group. In another, we can see that the replacement of diazo group. Is it clear? Okay. So, any doubts up to here? Yes, any doubts up to here? Okay. So by this, your Ramayana chapter is completed. Okay. So tomorrow we are going to start with the next chapter, that is biomolecules. Okay. So yes. So I shall end this session here. So we'll meet in tomorrow's class. Thank you.